Okay, hello everyone, welcome back for another demo lesson feedback. So this is our global feedback for the process question that I gave you guys yesterday. As usual, just have a quick look at the question there again, and I want to discuss your strengths. And I would say, overall, the question was answered quite well. You got the question answered, you got the overviews done. As usual, a few little language errors, be it vocabulary or grammar, but all in all, the question was answered, and you kind of did a good enough job on it. But I want to focus more on kind of like the weaknesses this week, and no, there weren't a lot of them. But I think it was just the way you approach the diagram. This is possibly because you haven't spent as much time on process questions as you have with the graph and chart questions. So I would say, even though your answers were good, they weren't as strong as the answers I was getting from all of you for the previous few weeks. So if you could just follow my cursor on screen here, that basically image A and image B, they're just the same. They're the same process, just two different parts of the same process. So I think some of you tried to kind of look at it like these are two different parts, but these are just think of them as like two descriptions of the same process. So another thing that a few of you guys did was where like you start talking about the structure as part of the process in your overview, and that's not necessarily like sure that it's situated on a cliff or a seawall. I mean, that's part of it, but the process is more to do what happens within the structure, and that would be the wave comes up, pushes the air through, which turns the turbine, which then generates electricity, and then the wave coming out creates pressure, which causes the air to get sucked back into the chamber, again continuing the spinning or the turning of the turbine, and then the electricity continues. So it's just like wave in, air up, wave out, air down. So that's pretty much all you've got there is that motion, and I'm sure that you understood that, but it didn't come across in some of your overviews. So with that in mind, and these are not by any stretch like the only mistakes that were made in overviews, but I thought that they were like a good example of the typical mistakes that were being made. So let me just read off the first one. Overall, it is a man-made linear process. It begins with a construction situated on a cliff. So now this sentence, it begins with a construction situated on a cliff. Now that there is more, that's not the beginning of the process. So maybe you're considering too far back where like the structure had to be constructed first on the cliff. So I mean that's true, but it's not the start of the process of what we're seeing in the diagram. So don't worry about the going too far back in time. Just look at what's happening in the diagram. Where rise and fall of tides are used to generate electricity with the help of a turbine. Now again, that is correct, but it's not really an overview in that it's just kind of describing what happens, whereas you should really be considering what Chris said about how many stages, linear, man-made, what happens at the end, what happens at the start, at the end, and all those questions. So you've just kind of overlooked it here. And I mean, this is still an acceptable overview, but I think it's just the approach has made it more confusing, and especially for the reader or the examiner. The next one here then, the second overview. Overall, it is a man-made linear process consisting of 4 stages. Okay, that's fine. It begins with the wave entering and also leaving the chamber, both producing air resulting in the generation of electricity. Both producing air resulting in the generation of electricity by the rotation of a turbine. So I would just say that like this producing air or producing air pressure, that's more in the middle. I wouldn't include that because now you're starting to go into too much detail. So like Chris said, you're just going to say what happens at the start and what happens at the end. So I say it begins with the wave entering, so that's fine, and I would not include and also leaving because that's kind of later that happens. So it begins with the wave entering. Forget about that. That would be in your details paragraph. The next part will be the details paragraph, and then finally the generation of electricity by the rotation of a turbine. That's fine, but again, it could have just been the generation of electricity being the end result. So try not to include too much from the middle of the process, in the same way that we would say for an overview for the charts or the tables or the graphs and whatnot, that you don't want to include too much information, and the same, too much detailed information, and the same is true of the process question. So really what you're looking for is just the start and the end, and try not to include anything from the middle. Now, this strong answer, normally I don't correct the grammar in these, but I just made a few adjustments in this one just because I thought that the answer was so strong already, and I just wanted to kind of alter it a little bit. So if you did write this answer, you'll see a few little changes, be it with grammar or vocabulary, a few small little bits. But as I was going through the questions, I take one paragraph from one student, another paragraph from another student, and kind of piece it together like that. But I was doing that today, and I got to this particular answer, and it had everything I wanted. It was like the approach to the question and the distribution of the details paragraphs was very similar to what I would have imagined I'd have done if I was writing this answer. So let me just go through it quickly here. So the illustrations demonstrate how electricity is produced by the power of waves. So very, very simple, like they haven't stretched themselves too far, they just went for accuracy, which obviously that's always what you want. So overall, a man-made structure that is placed on the cliff or seawall. So this is what we were saying earlier, that you can include that in your overview because, I mean, it's a part of what's in the diagram, and I guess it's important to know what you're looking at. But in this, it hasn't described this as part of the process. It's just describing this as where the process is. So it's placed on a cliff or seawall, and the process consists of 4 main phases. It begins with seawater filling a chamber, and the end result is the generation of electrical power. So it's very much the start and the end, nothing in between. So the first details paragraph was based on the first image, the first diagram. First of all, the chamber becomes filled with water by the power of a wave, and this causes the air that is inside the chamber up through the column, where it comes into contact with the turbine, which is also inside the column and causes it to spin. This rotation generates electricity, and the air passes back outside into the atmosphere. So that was the first diagram that they've described. And what's good here is that, I mean, a lot of the same components are in the second diagram, but this final paragraph has been written in a way where they haven't just ended up repeating everything that was said in the first details paragraph. In the diagram, the wave pulls the water out from the chamber, and this creates negative pressure where air from the atmosphere goes down through the column to fill the space, and this makes the turbine continue spinning in the same direction as before. So there's a little reference to the previous paragraph. This continued movement of the wave rotates the turbine and produces electricity. So I think just this answer is so strong in that it's covered everything. It's divided the details paragraphs very logically, one per diagram in this case. Overview is just concise, detailed enough, and even though they've used all the bits and pieces from Chris's overview. They've managed to include a little bit more to show that they kind of have a greater understanding of what an overview is. And then finally, like I said already, just very simple paraphrase. So I thought that was a great answer there. Finally, I just wanted to show you, these are 3, so rather than just taking short snippets, I took these 3, and I want you to get a pen and paper. I want you to correct these yourself first, and then I'll show you the corrections that I made. But before you start, I just want you to consider not just correcting the grammatical mistakes, but consider, based on what I just said in the rest of the video, like what errors have they made with content or with the description. And not just, I don't want you just correcting grammar and vocab mistakes, I want you correcting it in relation to what would be a better sentence in relation to the actual question that you answered. So pause the video for me now, and then I will give you 5 seconds before I show you my own answers. Okay, so that's what I came up with here. The first one. So this is more to do, there were some small grammar errors, there's a little punctuation where we needed a space here, but hit the seawall. So they don't actually hit the seawall, they just, the chamber and the whole structure is located next to a seawall, but it's not that the water doesn't actually hit the seawall in the diagram. So just to adjust that a bit, I came up with, first of all, waves enter a chamber which is located next to a seawall, and this pushes air from the chamber through a column. As well, for some of you who struggle with articles, so you can just see here this time I have a chamber because I haven't described it yet, and the chamber because I'm referencing back to the chamber I've already spoken about. In this next one, the phrase in figure B, it's not very natural. So in the second figure, in the second diagram, something like that, the wave goes back, excuse me, that should be back. So the wave goes back out to sea, which lets the air come back into the chamber through the column, and this causes the turbine to continue spinning in the same direction as before. So this is just kind of like, just not to be tripping over the information, just kind of take them one step at a time instead of just trying to lump too many things together. I've just underlined the word continue here because the word keep wasn't actually wrong, so I underlined it to remind myself. The word keep isn't actually wrong, only that it's a bit informal, so it's not as suitable as the word continue, even though, I mean, grammatically and everything was fine. This results in electricity being produced continuously. So this is just more like a vocabulary error here, so I just kind of switched it around to make it more accurate. And finally, this is to do, and this is something that I'd like you to pay a bit more attention to, looking at sample answers, be it mine or Chris's in the essay bank and all that, that you're not really using these pieces of vocabulary very well in your writing, because it seems like you're not aware of what is a noun, what is an adjective, what is an adverb, and how to kind of piece them together. So if you're going to say a four-stage process, so forget about man-made and linear at the moment. So this is a four-stage process. So this is a compound noun, and you're going to need to have the little hyphen here between, so a four-stage process. And then this is just relating to, you're adding the extra information, so comma, man-made, comma, linear. So a four-stage man-made linear process. It's just this stage linearly wouldn't really work. So just try to stick with the vocabulary that Chris gave you from the course, but also be more aware of how to use it accurately. And then starting with the wave entering into the chamber and ending with generated electricity lighting up a bulb. Now, this is completely fine, and I just wanted to talk about this phrase here, lighting up a bulb. Now, in the diagram, I think that the bulb is just to help the person looking at the diagram to understand that electricity is being generated, and in all likelihood there isn't actually a bulb there, it's more just a way to describe it. But this is completely fine, because there's nothing to say whether the bulb is or isn't there, and you've just followed what was given to you in the diagram, and you would never lose any marks for kind of misinterpreting it that way. There are a few times, not in this group, but from my experience teaching, before I start working here, that if you look at the question that we went through in yesterday's video about the hydroelectric dam, and it happened more than once that students thought that the water was coming from the river up past the turbine in through the penstock and back up into the reservoir, so like the water was coming the opposite direction that it actually is in a real hydroelectric dam. And again, it made no difference to the score that the person would get, because there were no arrows to indicate what direction the water was flowing, and even though it's correct, they have still used what they were given in the diagram to come up with their answer. So you would never worry about anything like that, in that if you've misinterpreted it, but there was no, you're not doing any damage. So again, I'm just talking about electricity lighting up a bulb. If you just said electricity being generated, that's fine. If you put in lighting up a bulb, which isn't realistically what would have happened, then it's still what's in the diagram, so that's fine. Okay, so that's pretty much all I wanted to say for today. As usual, if you have any questions about this or yesterday's lesson, just pop them into the comments below the video for me, and I'll get back to you as soon as possible. Okay, thank you all again. Bye-bye now.